Simplifying, multiplying, and dividing roots and radical expressions. First thing to notice, 5 squared is equal to 25. Taking the square root is doing the opposite of squaring. So if I take 25 and the square root, that's going to equal to 5. Or if I say 5 squared and I take the square root, that still equals to 5. We can all agree that 5 squared is the same as 25. So right here you should be able to see through simplification, the square root and the square cancel each other out. Now that's going to be the same thing for a cubed, a fourth, and a fifth. If I say 3125 to the fifth root, that's also going to give me a 5. Exponent of 5 and a root of 5 are opposites. Notice the index. The index is the number inside the radical. So over on the left we had a 5. A square root is when there's nothing written. The radical symbol is obvious, and the number inside is the radicand. Make sure you understand the vocabulary. Now the index can be odd or even. A square root, fourth root, etc. is an even index. And when you have an even index, you get 2 real roots. What that means is when I take the square root of a positive 9, I get 3 and I get negative 3. I have 2 real roots. Now if I have an even index and a negative radicand, meaning square root of negative 9, that means that there are 0 real roots. So we would say there's no solution. Now the odd index, you're only going to have 1. A fifth root of 3125 is only going to give me a positive 5. A cubed root of 27 is only going to give me a positive 3. Also with an odd index, I can take negatives. Let's run through a few examples really quickly. If I have the sixth root of 64, we would write that so that it looks like that. What you're asking yourself is, what number to the power of 6 is equal to 64? And that gives us an answer of 2. So 2 to the power of 6 is 64, which means the sixth root of 64 is equal to 2. So that would be my answer. Now notice, this is an even, so that means I'm going to have 2 or negative 2 as my answers. Next, cube root of negative 216. We'd write that cubed negative 216. Because it's odd, a negative is okay. So you're asking yourself, what number to the power of 3 is equal to negative 216? Well, negative 6 cubed, meaning negative 6 times negative 6 times negative 6 is negative 216. So that would be our answer. Because it's an odd, then I only have one answer. Next, I have the fourth root of negative 1024. Hopefully you see that I have an even index but a negative radicand. What that means is I'm going to have no solution because I cannot take an even root of a negative number. Here's 2 more examples. Try doing those on your own and check your answers. We're going to run through these very quickly. I suggest pausing, trying them on your own, and then coming back to see if you did them right. Cubed root of negative 27 is going to be negative 3. Fourth root of a negative 81 is no solution. Now this is interesting. I'm taking the square root of a negative, but it's being squared. Our order of operations tell us to do what's inside first. That means we're going to have the square root of negative 7 squared. Negative 7 squared is a positive 49, and the square root of 49 is negative 7 or positive 7. And last, the square root of a negative 49 is no solution. Now moving on to letters. I have the cubed root of a to the 6th times b to the 9th. Now there's 2 ways of doing this. The fast, easy way is knowing that I can divide. 6 divided by the index. Your exponent divided by the index. And the fast, easy answer on this is going to be a squared, because 6 divided by 3 is 2. B cubed, because 9 divided by 3 is 3. That's the fast, easy answer. Here's the longer, more complicated explanation. A to the power of 6. I need 3 things, because there's a cubed root, that are the exact same. A to the 6 breaks up into a squared times a squared times a squared. Because it's a cubed root, I need 3 of the same things. I have 3a squareds, gives me a squared. Next, I have a cubed root of b to the 9th. Well, b to the 9th breaks into b cubed times b cubed times b cubed. I need 3 of the same things because It's a cubed root, and that's where I get the b cubed. Now, I expect you to use the fast, easy way, exponent divided by index. So here I have the square root of a to the 18th b to the power of 4. If it's a square root, that means my index is 2. So 18 divided by 2 is equal to 9. It gives me a to the power of 9. And then b to the power of 4 divided by the index. 4 divided by 2 is 2. b to the power of 2. Now there's a trick here. Remember, these are letters. We don't know what the letters stand for. This letter could be a negative. I don't know. What we have to do then, because this is an odd exponent, and that only happens with odd exponents, is I need to write an absolute value. So the proper way of writing this is the absolute value of a to the 9th b squared. The square is going to make the b positive no matter what. The absolute value will make a to the 9th positive. Again, if it's an odd exponent coming out of a square root, then I have to put the absolute value signs. Next, again, I have an even index. So 8 divided by 4 is 2, so that gives me x squared. And then 12 divided by 4 is equal to 3. Now, because I have an even index and an odd exponent, I need the absolute values. Y to the power of 3 will be in absolute values. And last, the square root of 16 is going to be 4 or negative 4. X to the 10th, well, 10 divided by 2 is equal to 5. So that means I'm going to have an absolute value of x to the power of 5. Now this one, because we have a plus and minus, we probably don't need to put the absolute value signs on, but for completion's sake, I'll go ahead and put it on there. So this is the key point here. If you have an even root, which gives an odd exponent, then we use the absolute value. When simplifying radical expressions, use your order of operations. Use PEMDAS. Parentheses, exponents, multiplication, division, and then addition and subtraction. So if I'm looking at the radical, I see squares and I see addition, and realize the radical symbol is basically a set of parentheses, whatever's going on inside there. So first thing I'm going to do are my exponents. Then I can do my addition and subtraction because I'm still in those parentheses. And last, I can take care of the radical. The radical technically is an exponent, but because the parentheses supersede that, I'm saving the radical for the end. Again, here on the right, I have an invisible set of parentheses because the whole thing is in the radical. So what that's going to give me is the square root of 1 over 36. Easy way of doing this is to split it into two pieces. What is the square root of 1? And then what is the square root of 36? Gives me 1 over 6 and negative 1 over 6. What if they're not perfect squares? Now we start simplifying by using the primary tree. 24 breaks into 6 times 4. 6 breaks up into 2 times 3. 4 breaks up into a set of 2's. It's a square root, so that means I need 2 of the same thing. I take out 2 2's, which go on the outside of the house. The 2 times 3, they're individuals, so I'm left with 2 times 3 on the inside, which is 2 square root of 6. Now I have a similar problem, the square root of 50. This one I'm going to show you a shortcut. 50 breaks up into 25 times 2. Hopefully you can see that I can take the square root of 25, and that gives me a 5. 5 with the square root of 2 left over. This is a shortcut. If you don't like the shortcut, that's fine. Take it all the way down to the bottom, and you're left with a pair of 5's, and the pair of 5's come out. Multiplying radicals are very simple. You simply multiply the insides times each other, and then you multiply the outsides times each other. For example, here, the outsides are the 2 and the 3. Well, 2 times 3 gives me 6. Now I multiply the insides. The insides are 3 times 3, which gives me the square root of 9. Now you need to simplify whenever possible. I can take the square root of 9. The square root of 9 comes out to be 3. So what that gives me is 6 times 3, which is equal to 18. Now the next one makes things confusing because people don't see an inside times an outside. When you have a square up there, write it as it should be. A square means two things are multiplying times each other. What that it gives you is 4 the square root of 2 times another 4 square root of 2. Inside times inside. 2 times 2 gives you the square root of 4. Outside times outside. 4 times 4 gives you 16. I can take the square root of 4. 16 times 2 is equal to 32. I got the 4 becoming the 2 to give me the 32. Here's a few more multiplication problems. 3 times 12 gives me the square root of 36. Y times y is y squared. Notice there's an invisible 1 in front, so I didn't have anything to multiply. Always try to simplify at the end. The square root of 36 is 6. The square root of y squared is simply y. Here's a few more. I suggest trying these on your own, then resuming the video to see if you did them right. Gives you answers of 4, no solution, and 6. Here's a few more. Again, pause, try them on your own, and then see if you get them right. The first problem multiplies to 24x to the power of 6. Remember, I have a square root, so 6 divided by 2 gives me 3. So 2x to the power of 3, square root of 6 is left over. And the next one, we're working with a cubed root that multiplies to a negative 2 with 30 on the inside, x7, y3. So again, 3 divided by 3 gives me the y to the power of 1. X to the 7. Well, 7 divided by 3 leaves me with 2 and 1/3 left over. So the 2 came out. That's where I got the x squared. The extra 1 is why I have an x left inside. The cubed root of 30 does not simplify. Next, we have the 3 on the outside. 18 times 6 gave me 128. It's a 4th root, so that means I need 4 2's. I have one set of 4 2's, which came out, and 2 times 3 gave me the 6. And I have 3 2's left over, which is where I got the 6 left over on the inside. Meanwhile, 10 divided by 4 left me with 2, and 2 over 4 left over. That's where the a squared came from. And then b to the power of 2 cannot simplify with the 4th root. A couple more multiplication problems. Remember, outside times outside, inside times in. I have 2 times 1 gives me 2, square root. 8 times 4 is 32x squared. Well, the square root of x squared cancels out. 32 breaks into 4 times 8. 8 breaks up into 4 times 2. I have a set of 4's that can come out. That gives me 8x square root, and I have a 2 left over. Sometimes you're going to have to distribute. Square root of 8 times the square root of 10 gives me the square root of 80. Square root of 8 times the square root of 2 gives me the square root of 16. Always simplify. The square root of 16 is 4. The square root of 80 is 4 square root of 5 plus 4 square root of 2 times square root of 2 and square root of 2 times the square root of 10. Square root of 4 plus the square root of 20. That simplifies to 2 plus 2 root 5. Dividing radical expressions. When you have something that looks like this, you can change it to one radical. What I mean by that is 162 divided by 2. They're both a square root, so I can change it to one radical. That's going to give me the square root of 81, which is simply 9. Again, if you can simplify first, do. I have 12t divided by 6, which is simply the square root of 2t. There's nothing else that simplifies, and we're finished. Now, in the last two problems, I wanted to simplify the inside first. This problem, however, I see that 196 is a perfect square, and that x squared is also a perfect square. So I'm actually going to treat this as a 150 on top and then the square root of 196x squared on the bottom. The bottom half is going to give me 14x, and the top half is going to give me 5 square root of 6. Do not simplify the 6 and the 14 because the 6 is inside the radical and the 14 is not. For the next problem, you need to know your properties of fractions. I have two fractions here with a common denominator. It's written as 1, and I'm going to separate it into two separate fractions. I can do this because I have a common denominator. 15 divided by 5 gives me the square root of 3, plus 10 divided by 5 gives me the square root of 2. These are not like terms, and thus I am finished. Again, I have a perfect square on the bottom, and I have another perfect square on the bottom. So I'm going to take care of the bottom first, 2x squared. Then on top, we're going to simplify. And I get 6x cubed square root of 2x. I got the x cubed because 7 divided by 2, it's a square root, is equal to 3 with 1 left over. The 1 was the x inside. Now, I can still simplify. I can simplify the 6 and the 2, and then I can also simplify the x cubed and the x squared. That's going to give me 3x squared root of 2x. Here's two more problems. I suggest pausing, doing them on your own, and then coming back to make sure you got the answer correct. For the top one, I canceled everything out on the bottom first, and then I took the square root. For the bottom one, I reduced the 20 and the 45 by 5 to give me 4/9, which I was able to take the square root to get 2/3. The a on top, I did not simplify that because I had a perfect square on the bottom, so I left it alone. The b's, however, I simplified the b and the b squared, and I was able to take the square root. Something very, very important, you can never, ever, ever have a radical in the denominator. That's a big no-no. If you ever left with something with 7 over the square root of 2, that means that is a wrong answer, and we need to simplify that. We simplify that by rationalizing the denominator. What does that mean? If I have 7 over the square root of 2, first I want to look at that denominator. Take a look. If I have a square root of 2 and I multiply times negative another square root of 2, that's going to give me the square root of 4. Well, we simplify that to 2. So what that means is I take my original problem and I multiply the bottom by whatever that radical is to cancel it out. Remember fractions. Whatever I do to the bottom, I have to do to the top. What that gives me is 7 square root of 2 over square root of 2 times square root of 2 is the square root of 4. I can simplify that. 7 square root of 2 over the square root of 4 is 2. That's rationalizing the denominator, multiplying the bottom by a radical in order to get it to cancel out. Let's try this a couple more times. The denominator has an 8 in. Technically, I do not need to multiply by 8. I need a perfect square. I know the perfect square of 16 is 4. So I'm going to multiply the bottom by the square root of 2 because 8 times 2 is 16 and by n. Yes, you could have multiplied by 8, but that'd be a bigger number and you have to reduce later. Whatever I do to the bottom, I do to the top. The square root of 2n. 2 times 7 is the square root of 14n. On the bottom, I have the square root of 8 times 2 is 16n squared, which then simplifies to... Notice I cannot simplify the top and the bottom here because the top is an in radical and the bottom is not. Again, I have an 8, so I'm going to multiply the top and bottom by square root of 2. The top gives me square root of 10. The bottom gives me 4 square root of 16, 8 times 2. The square root of 16 is 4, so that gives me 4 times 4, which is the square root of 10 over 16. I have two more problems here. Try doing them on your own and then come back. So for the top one, we had to multiply by 125. Why? Because I need 4 5s. 5 times 5 times 5 times 5. The 125 gave me 3 of the 5s. This gave me the 4th 5. That way I can take the 4th root and get 5. Meanwhile, what you do to the bottom, you do to the top. 2 times 125 is 250. The one on the right, you had to be a little bit creative. I already had a perfect square with the x squared. So what I needed is I need to get rid of the 3. So I multiplied by another 3 in order to get 9. Then I almost have a perfect square with the y cubed. I only need one more y to get y to the power of 4. Then I can take the square root. Remember, whatever you do to the bottom, you do to the top. On top, the x to the power of 4 became x squared. The 15y are stuck inside the house. Meanwhile, the 9x squared y to the 4th became 3xy squared. Our final step there was to cancel. I had x squared on top and x on the bottom, so I had to reduce.